Good morning, everyone. Today is Wednesday. So today we will finish one more example on 1.8, and then we will talk about 3.3. So today you see the handouts 3.3, and you also see the useful formula for exam 1 and exam 2. Okay, so I hope you can figure this out. Oh, we have handout today. So fill this out, and then on Friday, I want to check on you. So fill this out tonight or tomorrow, and then on Friday, I will check on you. Okay, everybody? Yes. This formula is very important. You need that for the exam 2. And exam 1, go to the bottom. Okay, go to the bottom. You see the useful formula for exam 1 and exam 2? They're right here. So if you want to print more copy and tape it around your office, your room, feel free to print it out. And then do you see the answer? So this is the answer for the formula sheet of your exam 1. So my suggestion, don't copy it. Try to write down the formula by yourself first, and then check the answer. Is that clear, everybody? So exam 1, yes, these are the formula you need from exam 1. Exam 2, you might not need everything of this, but you might need some of them. Okay? So every exam, I will write down the formula sheet. So make sure you understand those and memorize all those formulas. Okay, everybody? And yes, every exam you will have one more. Okay. So Friday, I will check on you and to make sure you fill it out. All right. So last time we talked about solve polynomial inequalities. Right? Remember the steps? So you can look at the usual formula for sheet for exam 2 on the back. I write down the steps for graphing polynomial functions, the steps to solving polynomial inequalities, the steps to use rational zero theorem to factor polynomials of degree 3. So we haven't learned the last one yet. But do you see the middle one? I write down the steps for solving, handouts right there, solving polynomial inequalities. Look at the first one. Move all terms to the left-hand side so that the right-hand side is 0. And then second, what is the key word? Start with F. Factor. Everybody say factor. Factor the left-hand side completely. And you can see this problem is already factored. So our step 1 and step 2 is down. Okay? Then step 3. You set each factor equal to 0. Oh, by the way, step 2, if there are fractions, if there are more than, so this is a single fraction. If there are more than one fractions, you want to combine them into, we have three handouts. You want to combine them into a single fraction and then factor the numerator and denominator completely. Okay, step 3. Set each factor equal to 0 and solve for x. These are the critical values. Okay? And plot those values on the real number line. If you see greater than or equal or less than or equal, you draw closed circles. But if you have fractions, you draw closed circles on the numerator. Okay? Like this. These two numerator roots. So you put solid circle. And for denominator root, you always put open circle because the denominator cannot be 0. Right? Everybody? Therefore, we draw open circle for the denominator root. And then if you see greater than or less than, if you don't see an equal sign, then you always put open circle. Okay, everybody? And then when we draw it, find the leading coefficient, which is if you have the factor form, then the leading coefficient is you look at each factor, the leading coefficient of each factor, and then raise to the appropriate power and multiply them together. And we just want to know whether it's positive or negative. So you don't need to put in your calculator and figure out this number. You only need to know whether it's positive or negative. Okay, everybody? Mm-hmm. And if it's positive, then see, your leading coefficient is positive, then you start with the right upper corner. Yes, 3 handouts. And if the leading coefficient is negative, you start with the right lower corner. And when you connect the points, you look at the corresponding factor to see the multiplicity. If the multiplicity is odd, we cross the line. If the multiplicity is even, we bounce off. Okay, everybody? Yes. So, and then at the end, write down the interval notation. So, I give you the steps. Make sure you can remember the steps. So, imagine it's like cooking. Here's the recipe. So, how do you cook? How do you cook broccoli and beef? You need broccoli and beef, and then maybe you slice the beef and marinate it with garlic or put some sauce and then something like that. So you have a recipe. You follow the recipe and make sure you memorize this. Okay? And do lots of examples. Yeah, math is really do a lot of examples and then your muscle get used to it. Okay, so we do one more example. By the way, the other examples, I have solution on the website. I hope you can practice the remaining problems and you can do it on your own or you can work with that with your tutor, okay? And then the answer is online. So let's do one more example together. So this one. Okay. Many examples you have seen, the right hand side is 0. But do you see this problem, the right hand side is not 0? So our first steps, we need to move all the terms to the left hand side. So therefore we subtract 3, we get 2x over x minus 2, subtract 3, less than 0. Right, everybody? Yes. So, you see, there are two terms. It's not a single fraction. So if you see like more than one fractions or more than one terms, you want to combine them into a single fraction. Okay, everyone? So do not factor. So here, don't factor. We're not ready to factor because it's not a single fraction. So you want to combine them. What is the common denominator? X minus 2. Right. So this is x minus 2, 2x, and the 3, we divide it by x minus 2 and multiply by x minus 2. So far, so good, everybody? Ooh. Attendance. Okay, so attendance sheet, and also some of you haven't put down what time you want to meet me this week. I really, really want to help you. So please put down what time you want to meet. Okay, thank you. All right, so we keep going. We combine them. We get x minus 2. And then here we have 2x minus 3 times x minus 2. Let's do it slowly. This is a negative, okay? So when you break the parentheses, be careful, we need to change sign. So negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. So far, so good. Everyone? Okay. Combine the like terms 2x minus 3x is negative x. So negative x plus 6 over x minus 2 less than 0. Right? And great. This is a single fraction. And your right hand side is 0. So we want to factor completely. But it's already linear factor. Okay? It's already factored. We cannot factor further. This is linear. Right, everybody? So we're ready. We set each factor equal to 0. And find the critical number. So minus x plus 6, set it equal to 0. X minus 2, set it equal to 0. What is x? 6. What is x? 2, right? And these are the critical values. And then on the real number line, you plot those critical values. Which one is smaller? 2 is smaller. So 2 and 6. So here I just put a little bar here. 2 and 6. Now let's decide. Do we put open circle or solid circle? Open, because it's less than. Right? No matter it's on the numerator or denominator, it should be open circle. So open circle. So far, so good, everybody? All right. And then we keep going. Let me see. Some of you need 1.8. Okay, I don't have 1.8. So, yes, if you missed some handouts, feel free to go to our website and print it out. Then take notes there, okay? So now continue. Leading coefficients. Leading coefficient is you look at this one, okay? You look at this one, and you look at the leading coefficient of each factor. Here, what's the leading coefficient? Negative 1. Here, what's the leading coefficient? 1. So you look at this form as minus 1 over 1, which is negative 1. So it's negative. Right, everybody? A typical mistake is do not look at this one. Because if you look at this one, you get 2 over 1. No. Okay? Look at the factor. Okay? But if you don't have fraction, if you have polynomial, then you can look at the original one. Is that clear, everybody? Mm-hmm. Okay, negative. That means we start with the right upper or lower. Lower. And then 6. 6 corresponds to negative x plus 6. This is multiplicity. What's the multiplicity? 1. So it's odd, right? So we cross. How about 2? Cross. Multiplicity is 1, right? It's odd. So we cross. Okay. Then this is positive, this is negative, this is negative. What are we looking for? Less than 0. So it's above the line or below the line.
Is there a different way to tell how it goes, how it goes up and down?
Yeah, test point. Yeah, you pick a point on each interval and then you plug it in and see what's happening. Okay, so therefore, okay, we looking for negative. Therefore, write down the interval notation. Minus infinity, and then 2. Do we include the 2? No. And then here we have 6 to infinity. So far, so good, everybody? Mm-hmm. Okay, one thing I want to mention is if we have a polynomial inequality? This graph is the actual graph of the function on the left, okay? But if we have fractions, this is not the actual graph. Because you know, fractions, we should have vertical axis. So this picture just help us to solve the inequality. It's not the actual graph of the function. Is that clear, everybody? Mm-hmm. Yes. It's not the actual graph, but it still indicates whether it's positive or negative. Okay, but the actual graph might not look like that. Okay.
I'm sorry.
Yes.
How did you determine that it was negative infinity to
Oh, because it's below. So below is right here. So minus infinity to 2 not included. And then 6 not included to infinity.
How did you know that we needed that?
Oh, because it's less than 0. Yeah. If it's greater than 0, then you look at the positive. If it's less than 0, you look at the negative. Okay. Maybe it's good to know what is the actual graph. Okay, so the actual graph, let's see, go to Algebra. We have y equals negative x plus 6. Oh, and I put parentheses. Okay, divided by x minus 2. Okay, this is the actual graph. We are looking for when the y is negative. You see, it's negative. This piece is negative. So therefore, the x is from minus infinity to 2. And you don't include the 2 because we have a vertical axis. It's approaching to this line, but never go across it. And then here, also, less than 0 is this piece, not including that point. So do you see the x value is matched with what we had before? But this is the actual graph. And what we draw is not the actual graph, but it can still tell us the x value is such that the inequality is positive or negative. Okay, everybody? Mm-hmm. Yes. So that is what I want to point out.
What determines it from not crossing or from not getting 2?
Oh, because your denominator cannot be 0. Okay, so this is our function is okay. Think about it. When x goes to 2, what happens? So let's say if x is like 2.01, okay, and then when you plug in it, you get negative 2.01 plus 6 over 2.01 minus 2, right? And ooh, this is what like 3.99 over 0.01, right? And this is a very big number because you can multiply by 100, multiply by 100, and you get 399 over 1, so 399. So it just gets bigger, bigger, bigger. So when you get close to 2, and your y value either get bigger, 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 goes to infinity.
I get that, but like what determines that it doesn't go to 2?
Because the denominator cannot be 0. So it never equals to 2.
Oh, okay, that makes sense.
Yeah, it's just approaching it, but never go across it. Right. And in chapter 4, we talk about rational functions. Then we talk about vertical asymptotes and horizontal asymptotes. So we do know more chapter 4. Chapter 3 is the polynomial. Polynomial is continuous and no holes, no missing line, something like that, right? So it's very smooth. But in chapter 4, we talk about rational functions. Okay, so that is, so this example is good because the right hand side is non-zero, then you have to move to the left. And you have to combine into a single fraction. Then you start to factor. Okay, everybody? Yes. Any questions about 1.8? All good? Mm-hmm. Okay. Let's look at 3.3 division of polynomials. Okay. So last we call long division process from number. Okay, how do we divide number? So 39 divided by 4. You put 39 here and you put the 4 here, right? What do you want to put here? Hmm? What multiplied by 4 is less than 2? 9, right? You want to find the biggest number. So 9. 9 times 4 is 36, right? And then you use the first line, subtract the second line, and you get what? 3, right? Yes. So 9, okay, so 4, we call 4 is the divisor. Yes? Is that how you divide numbers? Mm-hmm. Yeah, okay. And the 9, we call the 9 is the quotient. And the 3, we call it the remainder. Okay, so this means 39 over 4 equals 9 plus remainder 3 over 4. Okay, so you get quotient plus the remainder over the divisor. So this is how we divide numbers. Today, we're going to divide polynomials. So we use the similar process. Okay. Yes. So, yeah, P of x divided. Okay, so P of x is like the numerator. That's the divisor. Denominator, that's the divisor. And you get a quotient plus remainder over the divisor. Okay, everybody? Okay. And usually you use long division when you have an improper fractions. So this is called improper fractions. That means the degree of the numerator is greater or equal to the degree of the denominator. It's like numbers, right? If 3 over 4 is a proper fraction, but 39 over 4 is an improper fraction. Right, everybody? So, therefore, okay, if I hide those two terms, this is the degree here is 1, the degree here is 2, so this is a proper fraction. Right? But now, here, the degree of the numerator is, and now the degree of the numerator is 4, right? And the degree of the denominator is 2. So that's why this is an improper fraction. So for improper fractions, we can do long division. Okay. So now how do we do it? We draw a long line here. Okay. You put the numerator inside. So 3x to the 4 minus 5x cubed minus, okay, we want to order it. Exactly. We have power 4, power 3, the next term should be power 2, but we don't have the power 2 term. So, but you can imagine it's like 0 times x squared. And then negative 20x and minus 5. So far, so good, everybody? Yes. this divided by x squared plus x plus 3. Okay, so let me also write down the steps. Okay, so step is like recipe. What do we do? First step, we want to reorder the dividend and divisor, like numerator and denominator. Okay, that's the first step. Step 2, you want to match. Okay, so what do we want to multiply? For example, you look at the first term. Here, you are thinking about, well, x squared multiplied by what? You get 3x to the 4th. Multiply. Look at the coefficients and look at the x power. Here, the coefficient is like 1, right? 1 multiplied by what number? You get 3. 3, right? 1 multiplied by 3, you get 3. Now look at the x power. This is x squared. This is x to the 4th. X squared multiplied by what to get x to the 4th? X squared. So the question mark is 3x squared. Very, very good. Oops, sorry. So we got, this is 3x squared. So you put 3x squared here. Okay, so this is step 2. You want to match. Okay, so you want to multiply. So you use this term to multiply all of them. So 3x squared multiplied by x squared, you get 3x to the 4, right? Oh, let me change back to purple color. And then 3x squared times x is positive, because this is positive. So you want x squared multiplied by something is 3x squared, right? So this is positive. Okay, now 3x squared times x is 3x cubed. 3x squared times 3 is 9x squared. Right? So step 2, you match. Okay, find the question mark. What multiply by this term to get this term. Then you multiply. Okay, use this term to multiply all the terms here, and then put it in the second line. Then you use the first line, subtract the second line. Okay. 3x to the 4th minus 3x to the 4th. Do you see they cancel? Yes. Keep in mind, we're doing subtraction. Negative 5x to the 3rd minus 3x to the 3rd is negative 2. Negative 5 minus 3. How about you guys take turns to answer my questions? Yes, there we go. Negative 5 minus 3. Negative 8. Yeah, so negative 8 x cubed. Yeah. 0 minus 9x squared. Yeah, negative 9x squared. And then if these two terms subtract 0, you just copy them, right? Negative 20x minus 5. Okay, so we can say step 3, repeat step 2. Okay, until you get the remainder is smaller degree. So remainder has smaller degree than the divisor. Okay, so you just keep going. Okay, now let me erase this. Okay, we made this error. Okay, now we look at this term and x squared. So x squared multiplied by what? You get negative ax cubed. Haley! X squared multiplied by what? You get negative 8x cubed. And x, yes, negative 8x. Right, everybody? Yes. So we put negative 8x here. So this is negative 8x. And you put it here. Now we multiply. So multiply. Negative 8x times x squared is negative ax cubed. Negative ax times x is... Dikema. Yes. Can you also tell me negative ax times 3? Yes, very good. And then we use the first line, subtract the second line. Back. This minus this is... this minus. Oh. Yeah, minus negative becomes plus. Oh, zero. Yes, and this always 0. Okay, negative 9x squared minus negative 8x squared. Positive or negative? Negative 1, because it's negative 9 plus 8. So, negative x squared. How about negative 20x minus negative 24x? Positive 4x. And minus 5 minus 0 is minus 5. Right? Okay, very good. Now we look at the minus x squared. So x squared times what is minus x squared? Jackson. 1 or negative? Yes, negative 1. Okay, negative 1. We multiply by x squared. What do we get? Yeah, negative 1 times x. Yeah, negative 1 times 3. Yeah, very good. Next, even. Negative x squared minus negative x squared.
0.
Yes. 4x minus negative x.
3x. Oh, 5x.
Yes. Yeah, everybody, make sure you're using first line to subtract the second line, so you change the line there. 5x. Minus 3 minus 5 minus negative 3 is negative 2. Yes. Oh, what's the degree of here? What's the degree of this? 1, right? 1. And what's the degree of the divisor? 2. See, this degree is smaller than that, so we can stop this process. This is our remainder. Okay, so this is the remainder. And this is the quotient. And that is the divisor. So therefore, what is our answer? So you can say our answer, this fraction equals to the quotient. Quotient is 3x squared minus 8x minus 1 plus the remainder. Remainder is 5x minus 2 over the divisor. X squared plus x plus 3. So far, so good, everybody? Yes. So this is how we divide polynomials. Step 1. What's step 1? We order it, right? And if some term that you're missing, you put a zero kind of thing, right? Step two, match, and then multiply, and then use the first line, subtract the second line. And make sure when you subtract each term, you change the sign. Right? You ready? And then you repeat the process until the remainder has a smaller degree than the divisor. Is that clear, everybody? Now it's your turn. Please do this example. Okay. So do this practice. Execute. Oh, then you can do right? So you get 6x squared. Put it under
Look at the power. Yeah.
times question mark equals 8 x to the 4. And then 3 times 1 we have 15 to the 6. And then x squared times 1 is x squared. Yes, x squared. And then x squared plus 6. 6 times 6. So it's better to write. Oh, oh, when you multiply, oh, okay. Do you put 6x squared here? It's 3 times, oh yeah, then you can put it here. And then when you multiply, you see this is 18. It's not 6. That's how the first term always is. Yeah, that's good. Yeah. Wait, plus 2 or plus 1?
Plus one is.
It is?
Oh, yep, you're right.
Ah.
We forgot to bring that down.
Okay, so you multiply, this times this is 18x to the 4, and then 6x squared times 1 is, yes, good, that's good. Oh, how are you? And how about you? Okay, so put like this example, put a line there. Oh, you see x squared. Put it under here. Don't put it under the cube. Okay, let's check our work together. So this is 3.3. Okay. So here we have dividends divided by 3x squared plus 1. And once multiplied by 3x squared to get 18x to the 4, that is 6x squared, right, everybody? Yes? So 6x squared. And then you multiply. So 6x squared times 3x squared is 18x to the 4. 6x squared times 1 is 6x squared, but put it under the 9x squared. Okay. And you use first line, subtract the second line. So this cancel, 9x squared minus 6x squared is 3x squared. And then 3x plus 2, copy down. And then you look at, okay, 3x squared. Oh, you think 3x squared, 3x squared? So 3x squared times 1 is 3x squared. Right, everybody? And then you multiply. You get 3x squared. And you multiply. See, 1. You put the 1 under the 2. Don't put it under the x. Then 3x squared minus 3x squared, so on. So you get 3x. 2 minus 1 is 1. So therefore, the quotient, 6x squared plus 1, plus the remainder, 3x plus 1 over the divisor. Okay, everybody? So this is long division. And now, let's learn synthetic division. So long division works for general, no matter what your denominator is. Okay? The synthetic division only works for linear factor, linear denominator, and with the leading coefficient is 1. Okay. You finished the notes, everybody? Okay. So synthetic division is a quicker way to divide something of the form x minus c. You see, this is a linear term. Okay, so linear, which means the degree has to be 1. And also, you see the coefficient of x has to be 1. So if you have something else, like 3x squared plus 2x minus 5, can you do synthetic division? No. If you have 2x plus 11, can you do synthetic division? No, because the degree is not 1 and because the coefficient is not 1. So synthetic division is so restricted. It only works for the form x minus c. Okay, your c could be positive, c could be negative. Okay, everybody? So if you have x plus 5, that's okay. The c is negative 5. Okay. All right, so look at this problem. So we want to use synthetic division. So how does that work? Look at the denominator. So x minus 2. So that corresponds to the root is 2. Okay. Why do I say that? Do you remember usually when we have like x minus 2, 3x plus 1 equal to 0, you set x minus 2 equal to 0, and you set 3x plus 1 equal to 0, and then you find the root. The root is 2, and this one, what's the root? Negative 1/3, right? So if you have x minus 2, that means the root is 2, not negative 2. Is that clear, everybody? So what you do is you draw a symbol like that. And then you put the coefficients. So you put the coefficients of the numerator. Therefore, you get 1x to the fourth and negative 1x cubed plus 1x squared, negative 1x, and plus 2. Okay? So be careful if we miss some x power, put 0. For example, if you don't have x squared, then you just put the 0 on the spot of x squared. Is that clear, everybody? You put the coefficient there. And then you put the root right here. So you put the root right here. Okay, now we start the process. The process. 1, you down. So this number 1, move down. Okay, move down. And then step 2. Okay, multiply the root and the leading coefficients and write it in the next column. Right in the next column. Okay, so step 2 is you use the roots multiplied by this number. 2 times 1 is what? 2. And you put it in the next column. So this is step 2. Okay, use the roots multiply the leading coefficient and then put it in the next column. Okay. And then step 3, you want to add the second column. Minus 1 plus 2 is minus 1 plus 2 is 1. Okay, 1. So that's the third step. And then you repeat the process. Okay, so we repeat the process. You use 2 multiplied by 1. What's that? 2. And you put it in the next column. And then you add them. Okay, let's see. David. Oh, well, Peter first. Okay, Peter. 1 plus 2 is 3. And then you use 2 multiply by 3, you get what? 6. You put it in the next column. Okay, so multiply by 3 and you get 6. David! Yes, minus 1 plus 6 is 5. And then what do you do? 2 multiplied by 5 is 10. And you put it in the next column. Okay. Dylan! 2 plus 10 is 12. Okay. What do we do with this number? What do they mean? The last number is the remainder. The remaining numbers, they correspond to the quotients. So, okay, what's the quotient? The constant term is 5. And then you increase the power. So you will get what? 3x. And the next one you get 1x squared. The next one you get 1 and then it's x cubed. Is that okay, everybody? That is the quotient. These are the coefficients of the x powers. Plus the remainder, which is 12 over divisor is x minus 2. So this is what it means. Okay? So we will continue on Friday. Please fill this out, the formula sheet. I will check your formula sheet on Friday. Have a nice day. Make sure you watch the lecture video for the notes.
send you a different one.
Yeah.
I emailed you a paper about excuse me from class on Friday.
Oh, yeah. That's
It's
good.
good?
Yeah.
Okay.
Thank you.
Good morning.
Good morning.